Okay, Joe, I think you said mirror, like a mirror does. We're going to talk about the difference of inversion versus a mirror plane. So can you guess what the next symmetry operation is? Yes. Mirror planes. In the Schoenfly symbols, this is given the symbol sigma, typically with some subscript to indicate under what planes this mirror plane is. So if it were in the xy plane, it would be sigma sub xy. Or m for HM notation. It is for mirror, M first for M, but there are two different symbols. These are typically used for point groups, for molecules. These are typically used for crystals because we're going to see there are some translational symmetries that single molecules don't have because they don't have translational symmetry. How many times can I say symmetry in a row? All right, here we go. All right, how would you describe a mirror plane? Yeah. Yep, it's a plane of reflection. Okay, so as an example, let's say I have a 2D coordinate system. That's y, that's x. And I have a point at x, y, like that. What color do we want the mirror plane to be? Purple? I don't have purple. Blue? Blue it is. I'm going to draw the mirror plane just cutting through the y-axis. So this is considered a y plane. However, how many dimensions do we actually have? 3. We typically don't have 2 dimensions. We would normally have to indicate 2 directions here, but we only need 1 for this example because we're dealing with a 2D plane. Okay, we're going to reflect this thing about what? Right, so we're going to reflect it on the y-axis, so we're going to end up, where is my new point going to be? In which quadrant?
2.
Oh no, I forget the numbering. Is it 2?
Yeah, I think so.
1, 2, 3, 4. Okay. Left is this way. That's the problem. Okay, we're going to get here. In that quadrant.
Negative x.
Yes, it will be negative x, y. Everybody feel comfortable with that one? Okay, let's look at a molecule. BH3. If we draw the Lewis structure, BH3, we get this. Okay, we know this is a 3-dimensional object. Oh no, my yellow chalk! It's a shame. All right. Glad it wasn't my kid. I'm glad I'm just dropping chalk today. I'm like doing bad. Anyways, we know this object is actually a 3-dimensional object, but what is the molecular shape of BH3? Yep, trigonal planar, meaning it's flat, correct? So we can look at it in regards to the board. Where do you see a mirror plane? Okay, yep, so I saw the first Navy SEAL hand signal going that way. Yes, there's a sigma plane that way. Mirror plane, cutting this thing in half and reflecting those points. Any other mirror planes that you see? Yes. We'll call this one prime. prime. Like that. So how many mirror planes does this system have? 3. High orders of symmetry. Okay? Do you see it? Okay. Yes. Where is there another mirror? There is another mirror plane. Yep. This would actually, we'll give it a sub H for reasons that you don't have to know about right now, but Lily knows. There's one cutting the molecule in half. The plane of the board is another mirror plane.
Oh, okay, I can see it.
Yep.
I can see it.
So how many mirror planes? 4. Yep. Symmetry operations creep up on you. Okay. Again, we already said the symbols, but what symbols are we going to elect to use? Yep, sigma or M. And remember, there's usually a subscript underneath there to indicate the direction. Okay, let's look at a matrix operation for this thing. Let's be careful about time. Operation for a mirror plane. We're going to go with the XZ plane because that's just what I picked. What symbol would we give it in the Schoenfly symbols? Sigma what? Yeah. Nope, not. Sorry, XZ, yeah. Okay. We have our transformation matrix. We have our original coordinates. What's going to happen to our new coordinates? Should we draw a picture?
Please.
Yes, you're right, Katie. Positive Z. Do we need a picture or are we okay? Okay. So we got to do that transformation. What's the matrix going to look like? Yeah, along the diagonal, correct? Yeah. There we go. Okay.